Dear students, I am Aditya Chakraborty, lecturer in electrical engineering of Sri Ramakrishna Institute of Science and Technology. Today I am going to discuss about the part 4 lecture of my boiler, steam turbine and steam engine. So now the first slide is the modern high pressure boiler. So what is modern high pressure boiler? When the high pressure steam is released through the boiler nozzle to drive some mechanical work or turbine, that type of boiler is called high pressure boiler. So there are 5 types of high pressure boiler. Number 1, Lemmon Boiler. Number 2, Benson Boiler. Number 3, Loeffler Boiler. Number 4, Skimming and Hardman Boiler. And number 5 is a Velox Boiler. So now the first one is a Lemmon Boiler. So here you can see the diagram of a Lemmon boiler. The various parts of Lemmon's boiler are chimney, air preheater, feed pump, speed control, storage and separating drum, circulating pump, combustion chamber, convective evaporator, superheater, economizer and blower. So the Lemmon boiler is invented by scientist Lemmon in the year of 1925. This boiler is a water tube type. Actually, most of the modern high pressure boilers are water tube type. The water circulation and schematic location of different components are shown in the figure. This boiler incorporates water circulation in the tubes surrounded by the gases. That means when the water is flowing through the tubes, these surrounding gases heated the water and hence the steam is produced. Water is supplied through an economizer to separating and storage drum which contains a feed regulator, and by the help of this feed regulator the speed of the water which is collected in the storage drum is controlled. That means the feed pump speed control is done by this feed regulator. Most of the sensible heat is supplied to the feed water passing through the economizer. From the drum, a centrifugal pump circulates about 8 to 10 times of quantity of water evaporated. The circulating pump passes water to radiant evaporator or water holes. This steam and water pass to a convective evaporator and again to the drum. And from the drum, it is released to the superheater and hence the steam is superheated and saturated and supplied to the turbine or other mechanical process. So this boiler is capable of generating 40 to 50 tons of superheated steam at about 1600 degrees Celsius at a pressure of 1300 kilonewton per centimeter square. So this is the first one. Now the next one is the Benson boiler. Here you can see the image of a Benson boiler. So several parts of Benson boiler are chimney, radiant evaporator, main steam outlet, throttle valve, superheater, evaporator, feed pump, air preheater and blower. So there is a limitation of Lemmon boiler. So when the water is heated in the water tube, there is a bubble is produced in the water tube, and to overcome this type of limitation, the Benson boiler is invented by Benson. And Mark Benson developed the boiler where the pressure are raised to the critical value, that is 2200 Newton per centimeter. The steam and water would have the same density and therefore danger of bubble formation can be totally eliminated. So you can see here the figure or layout of the Benson boiler. So the Benson boiler are drumless type. There is no storage drum is provided in this boiler. The feed water is pumped through the economizer radiant and convective evaporators and superheater. And the boiler pressure is maintained as a critical pressure, as I have already said. And in this boiler, if distilled water is not used, heavy deposits of sludge occur. So in case of Benson boiler, the water which is used to produce the steam must be distilled. This difficulty can be avoided if the evaporator is cleaned regularly. The steam pressure is in the boiler is 1600 Newton per centimeter square. So this is the Benson boiler. Now the next one is the advantage of Benson boiler. So number one, total weight of boiler is reduced due to absence of drum. So there is no boiler drum is provided, so it is must less in weight. Number two, low cost of transport. Number three, the boiler can be constructed easily and quickly because there is less number of auxiliary parts are installed in this boiler. Number four, it is economic to operate. And number five, quick starting and can be reach full capacity operation in short time. It can be operated in a short time, or starting and boiling process is done in a very few short time. Now the next one is the low floor boiler. Here you can see the image of low floor boiler. It is also a high pressure boiler. There is chimney, hot air vent, convection superheater, steam regulated pump, evaporator drum, feed pump, economizer, air preheater and blower. These are the several parts of low floor boiler. So this boiler use circulation of steam instead of water. That is, steam is circulated instead of water, as like in Lemmon Boiler or Benson Boiler. In case of Lemmon and Benson Boiler, where the water is circulated, but in case of low floor boiler, there is steam is circulated. Thus, the difficulty of experience in Lemmon Boiler about deposition of salt and sediment in boiler tubes is avoided. So here, the salt and sediments which are present in the water is not deposited in the water tube because the steam is circulated in low floor boiler. Now this boiler has advantage of forced circulation and indirect heating. In this boiler, steam is used as heat carrying and heat absorbing medium. That means there is a better advantage of forced circulation and indirect heating. The steam which is passing through the tube, it carries the heat absorbing medium. This boiler uses circulation of steam rather than that of water. And this boiler has economizer and superheater units in the path of gases from furnace to chimney. An evaporator drum is outside the boiler. The portion of main superheated steam is utilized for external use, whereas the remainder passes on the evaporator drum. This giving superheat to water coming from economizer, and steam is generated equal to the steam bypassed. The steam circulating pump draws the saturated steam from the evaporator drum and passes it through the radiant and convective superheater. Thus, nozzle distributing the superheated steam throughout the water in the drum are of special design to avoid the priming and noise. Priming means there is there is a water droplet or water molecule is present with the steam, then it is difficult to rotate the turbine, or there is a damage of turbine can be occurred due to this reason. So this priming can be avoided by this way. And this boiler can carry higher salt concentration that any other type, is more compact than indirect heating natural circulation boilers. Therefore, it is used for C. Transport power generation. The low floor boiler of generating capacity 100 tons per hour and pressure of 1500 Newton per centimeter square. Now the Skimming and Hardman boiler. Here you can see the image of a Skimming and Hardman boiler. The several parts: a chimney, blower, steam outlet, superheater, air preheater, primary evaporator, combustion chamber, and a furnace where coal is ignited, fuel tank or hot well, feed pump, water drum, primary separator, forced for forced circulation, the feed preheater, secondary evaporator drum, pressure gauge, etc. So now this figure shows the arrangement of this such type of boiler. There are two pressure circuits used in exchange the energy. In the primary circuit, steam is passed through the submerged heating coil located in the evaporator drum, and the high pressure steam of primary circuit possesses sufficient thermal heat to produce steam at 500 Newton per centimeter with a heat transfer rate 2000 watt per m. This main steam is first through the superheater placed in the uptake and then to the application point. That means where the steam is needed to drive a process. The condensate of high pressure primary circuit steam is circulated through the water drum where feed water is heated to its saturation temperature. In the primary circuit, natural circulation is used. For purpose of safety, a combined pressure gauge and thermometer are fitted to the primary circuit. There is an arrangement is provided for making distilled water for primary circuit. To avoid it or to avoid production of sludge and sedimentation of salt, this distilled water is used. Now the advantage of Skimming and Hardman boiler. Since if use distilled water in primary circuit, there are less chance of overheating or burning of the highly heated components as there is no danger of salt depletion. If the salt is present, then salt heated very quickly. So this overheating problem can be eliminated by using the distilled water. There is no chance of interruption of the circulation either by rust or other materials due to use of distilled water. The feed water outside the heating coil and hence it is easy to remove the salt deposit. Due to high thermal and water capacity, wide fluctuation of load are allowed without undue priming or abnormal increase in the primary pressure. The last one is the absence of water riser in the drum and the moderate temperature difference across the heating coil allow evaporation to produce without priming. Now the next one is the Velox boiler. Here you can see the image of Velox boiler. In this boiler, the velocity of the gas exceeds the velocity of the sound. The heat is transferred from the gas at a much greater rate than the rate achieved with the subsonic flow. Therefore, in the Velox boiler, it is possible to achieve the large amount of heat transfer from the given surface area. So, the velocity of the gas exceeds the velocity of the sound. Due to that very reason, a large amount of heat transfer is possible in Velox boiler. In the Velox boiler, air is compressed to 20 to 50 Newton per centimeter square by an air compressor run by a gas turbine before supplying the combustion chamber. The object of this compression is to secure a supersonic velocity of the gases passing through the combustion chamber and gas tube. As a result of this high rate of heat released are achieved, the capacity of this boiler is limited to about 100 tons per hour because of large power is required to run the air compressor, about 16,000 kilowatts. So the auxiliary power is very much required in case of Velox boiler, that is 16,000 kilowatt to run the compressor. The fuel and air are injected downwards into a vertical combustion chamber which consists of annuals, gas tubes and annuals, water tubes. The products of combustion are deflected upward into the evaporator tubes which consist of an outer annuals through which the water evaporated is circulated at a high velocity. The heat is transferred from gases to the water at a very high rate. The mixture of water and steam formed is then passes into a separator from which the separated steam passes to the superheater to separate the steam and saturate the steam. The water removed from steam in the separator is again passed into the water tubes along with the preheated feed water coming from the economizer. So by this process the efficiency of this boiler is increased. And now the advantage of Velox boiler. It has high rates of heat transfer. It is compact steam generating unit. It is capable of quick starting by the help of the compressor. It requires low excess air as compressed air is used. The control is entirely automatic and thermal efficiency is very high. That is the main advantage of Velox boiler. That's all for today. Thank you.